Good afternoon. Hi, everyone. My name is Paul Maddox. I'm a solutions architect at AWS. I specialize in containers, amongst a few other things. I'm here today to talk about how best to run containers on AWS. Before I dig in, can I get a show of... This is the Apple world of dongles now that we have to live with USB-C. Let me plug that back in. Before I start, can I get a show of hands of the room of who's using containers today? You don't count. I know you are. Okay, who's using them in production? Okay, good number, good number. Okay. So, when I speak to customers around Docker and containers, a lot of people I speak to are running containers in development environments, test environments, and it's pretty easy to do, right? You can very quickly Dockerize a traditional application, wrap a Docker container around it, and launch it on your machine. And yeah, using Docker, it's really easy, right? So with that in mind, we, a couple of years ago at AWS, had customers come into us and saying, hey, AWS, can you do a Docker thing for us? Like, we want some sort of Docker. What can you do? And we sort of sat there a bit confused. You know, you can run Docker on EC2 yourselves, no problem. And actually, when we dug into it, people wanted a bit more than that. So when it comes to taking containers to production and scaling up, scaling out, there's a bit more to think about. And this is where our container orchestration engines come in. So I skipped a slide here. Today, we're going to cover in depth a couple of container orchestration options that you have available to you on AWS. So we're going to talk about Amazon ECS, the EC2 container service. We're going to go into detail on how to deploy it, how to get a cluster up and running, some of the key features, some of the things you need to know to manage an ECS cluster and operationally wise, how do you monitor it, etc. And then we're going to talk around other container options as well, like Kubernetes, and talk about how to run that on AWS. What the implications are there for things like management, how you deploy. And to do that, we're going to have a good friend of mine, Rick, from Ticketmaster, come on stage and talk about their usage of Kubernetes on AWS and their experience running it. So, as I mentioned, moving to production is harder. Typically, when you take containers into production away from just a developer's laptop, there's a lot of questions that come up. Things like, how do I deploy my containers? How do I actually get them on the hosts? How do I do that in a way that ensures zero downtime when I'm updating containers? Or maybe I want to run blue-green deployments and get my containers up and running side by side and manage the traffic across them. Canary-type deployments as well. Once I've got my containers deployed, how do I keep them there? How do I keep them running? How do I keep them alive? How do I health check them? How do I make sure that if a container fails for whatever reason, that something brings that container back up? How can I get my containers to talk to each other? So service discovery, getting from one container to another container. How do they find out about each other and talk to each other? Do I link them together? Do I use console, some kind of server discovery? And then how can you configure your containers? So how do you actually get runtime parameters into your containers? So you don't really want to be baking into your container or your configuration data like database host names and passwords and that kind of stuff, right? You want one container build that progresses through all of your different environments. So how do I configure my containers at runtimes? And how do I do that with secrets? How do I best secure my secrets? And then finally, the last question that comes up a lot in conversations I have with customers is, so we're getting to that world where we've got a big pool of compute, and we've got our containers on them. How do we optimize that pool of compute? Maybe I've got some containers that I want to run as highly available as possible over multiple availability zones. Maybe I've got some like dev, test, etc., where actually availability isn't my primary optimization factor. Actually, it's cost. So how do I optimize that? So we're going to talk about a couple of container orchestrations engines that are out there today. I mentioned ECS. We're going to dive into ECS first. But before I do, I just want to start with our main goal at AWS here is about choice. Our goal is to be the best place for you to run your containers, regardless of which choice of container orchestration engine you use. So I'm going to talk about ECS here. Rick's going to talk about Kubernetes. we'll help you run whatever you want on AWS. Our goal is to be the best place for containers, full stop. So with that, let's dive into ECS a bit and talk about some of the key functions and features and functionality. When we built ECS, one of our main goals was to build a container orchestration system that was super easy for customers to use, right? No software to manage. Okay, it's a managed service. So the actual scheduling engine, et cetera, runs in our part of the world, right? It's not in your AWS account. It's not something that you have to maintain, manage, patch, install, update, et cetera. We wanted to build something that had really deep integration with other AWS services. So things like load balancers, automatically registering containers with load balancers, for example. Auto-scaling, being able to not only scale in and out on the pool of compute that your containers run on, but also actually scaling up and down the number of containers as well in an automated way. Things like logging and centralized logging and integration with things like CloudWatch Logs, networking and ID access. We've got IAM in AWS, and how do I integrate permissions on my clusters with IAM? Things like monitoring as well. And these deep integrations are one of the main strengths of ECS here that you'll find. So let's dig into a few of these. We also wanted to make sure that security and compliance they're really important to us and to our customers as well. So with ECS, you have PCI certification for handling credit cards. You have ISO 27001. You have strong integration with things like IAM roles per container. So you can scope down your permissions in a really fine-grained manner. So even if you're not handling credit card data, even if you're not that interested in ISO 27001, just know that because some of our customers are, everybody's reaping the benefits of that when you use ECS. So the key components of ECS, you have the main ECS service. This is the ship in the middle here, and this is the bit that's managed by AWS, the bit that you don't need to run or patch, et cetera, yourself. Below that, you have container instances. These are EC2 instances, Windows or Linux, and they run Docker, and they run our ECS agent. This is an open source agent that sits on the hosts and talks to the main backend, to the ECS service, and says, hey, what containers should I be running, et cetera. I've got this much resources. So that when you pass in a task definition, which is how you define your containers within ECS, you have a JSON task definition, you list the containers, and then you deploy it. So it's your unit of deployment. When you deploy a task definition, the ECS service is able to communicate with all of your different instances and decide where it should put those tasks. One of the nice things here is that these container instances, they're just EC2 instances. We provide an optimized army that has Docker pre-installed and some of the kernel parameters tweaked, et cetera, for Docker, and it has our agent baked in. But ultimately, you could create your own, maybe from your own master image or army or something if you have a golden build internally. They're just EC2 machines. So how do I deploy ECS? How do I get a cluster up and running? There's a number of different ways to do this. Things like CloudFormation, things like command line, via our UI. I'm going to show you here the ECS CLI. So we have the AWS CLI. Probably quite a few of you here will have used it. For some of our services like Beanstalk and ECS, we have a higher level abstracted CLI that just makes life a bit easier. So we have the ECS CLI, and it has this simple up command. And this is going to bring up a cluster for you, right, with one command here. And you can provide things like the key pair and which VPC you want to deploy it into, which subnets, security rules, et cetera. So there's a lot of flexibility there. You can also use the UI to deploy your cluster as well. Nice simple way, or CloudFormation. The UI is actually a really nice way of deploying to Spot. So I don't know how familiar you are with Spot Market, but you can basically bid on unused capacity in our data centers, see up to 95% cost savings. So really nice place to run dev test workloads. I have customers that use this for production as well, but a lot of people will just use this for dev test. So with Spot Fleet, you can say, I want a cluster made up of any of these particular instance types, and I want this much CPU or this much memory. And you can be really flexible, right? And you can just build up that pool of compute and get the cost savings that come with Spot. So you can do this via the CLI, but the UI just makes it really easy to do here. Let's talk about how to deploy a service. And once you have your cluster up and running, one of the easiest ways to deploy a service is to use Docker Compose. So Docker Compose, if you've used Docker Compose before, it allows you to specify a set of containers in a Compose file and run it locally on your machine with Docker. Actually, the ECS CLI can interact with those Compose files. So you can say Docker Compose up to run it locally, and then when you're ready to run it on ECS, you can just use ECS CLI Compose. And this is going to bring up a service. It's going to give you a chance to specify some of the ECS-specific information for that service, like which IAM role should your containers use? Which load balancer should the containers register with? Or maybe an ALB, you're going to be working with target groups there. And then just a quick way of seeing which containers you've got running. So really nice, easy to use CLI. Let's talk a bit about resource optimization. This was one of the other questions I had up at the beginning, is once you have your pool of compute, how best do you optimize that pool of compute? Well, with ECS, you have a number of controls available to you. The first is placement strategies. So for a task, for a service that you run on ECS, you can choose how you want those containers placed on your cluster. So you can choose maybe to bin pack them. Maybe you want your cluster to have the minimum possible number of hosts to optimize on cost. So get those containers packed really tightly and don't worry too much about high availability. Or maybe you want the opposite. Maybe you want to spread your containers out as much as possible for high availability. Maybe you've got groups of containers that you want to keep together, right? So by using Affinity, you can say, OK, always deploy this container or this group of containers with this one alongside each other on a host. Or maybe you've got a scenario where containers should always be on distinct instances. So if you're using the UI with ECS, when you deploy your service, this is just a drop-down you can pick from and choose from. So really powerful. You can specify it as well programmatically with the CLI and SDKs, etc. You also have placement constraints. So these are a way of saying, in a bit more granular level, where containers should be deployed to. So for example, if I'm deploying a container that does a load of GPU-based calculations, I'm only going to want to deploy that to GPU instances. So I could, when I define that service and deploy it, I could say, put a placement constraint on to only run on this particular type of instance. Or maybe only on instances that are running this particular army. So if you've used Kubernetes, this is very similar to taints, for example, and sorry? Tolerances, taints and tolerances, thank you. One of the other questions I had was around service discovery. You've got your containers deployed, how do you get them talking to each other? There are two main options I see customers using with ECS. The first up is to use load balancers. So when you register a service in ECS, you're given the option to attach it to a load balancer. And what ECS is going to do behind the scenes is whenever a container spins up for that service anywhere on your cluster, it's automatically going to register it with the load balancer. And when the task finishes, when the container goes away, it's going to unregister it from the load balancer. So using something like this, you can use our application load balancer here in the middle and actually send traffic to different microservices based on host-based routing or path-based routing. So really easy way to just do that service discovery. The other main way I see used is DNS-based. And I like this one because it uses a really cool feature of ECS. So ECS has an event stream coming off it. Anything that happens on your cluster, new containers get scheduled and spun up, for example, fires off an event. And you can hook Lambda functions up to that event stream. So you can react and do things based on what's happening inside your cluster. So actually with Lambda, it's really easy to receive one of these events and register in DNS a container when it starts. And when the container dies, unregister it from DNS. So this is really useful if you're using, for example, UDP protocol, which you're not going to be able to do with the load balancer. This is really useful if you want to use DNS-based service discovery, right? So you have a couple of options. You can register as an A record, for example, as an IP address and have a round robin of IP addresses. If you want the port as well in there, you can use SRV records. This is a really easy way to get up and running with DNS-based service discovery. Next thing I want to talk about is config management. How do I do configs and secrets within ECS? So we have a service called the EC2 parameter store. Has anyone played with this? Not many people. It's hidden away in the EC2 console, right? You can find it in the EC2 tab of the console. And it's a configuration store, right? It allows you to put configuration data in, things like key value pairs, and retrieve them as well. It's really useful for secrets. You can automatically encrypt your key value data with KMS, our key management service. So one really nice pattern here is to use the IAM role integration with ECS to say, this container can retrieve this bit of configuration data. And only this container can retrieve it, and only this container can decrypt it with the KMS key. So you can have really granular container-based secrets baked in with the security of IAM. So very powerful feature that I think we could publicize more, because not enough people have seen this. How do you do monitoring and logging with ECS? So has anyone here played with Xray? No. Xray is a really, really cool distributed tracing service baked into AWS. You can use it with containers and ECS. You can use it with Lambda. You can use it with EC2. Very, very flexible. And it allows you to automatically build up a service map of all of your microservices and their interactions with AWS services and third-party services. So it requires you to make a few modifications to your applications. Okay, so if I wanted to trace a Node.js application, for example, when I initiate the AWS SDK in my app, in my Node code, I can just wrap that with the Xray function. Automatically then, from then on, all of my interactions with AWS services are going to be graphed, mapped for me. I'm going to see things like average transactions per second. I'm going to see things like the failure rates. So the colors here represent HTTP response codes from those services. So very easily, you can get up and running and get this bird's eye view of all your microservices. We have a guide on our website that shows exactly how to set this up with ECS, but you can use this no matter what container orchestration engine you're using, to be honest. What's cool is you can deep dive a bit here and see, OK, for these particular URLs that are called in my application, where's my latency? Right? So we can see here, in this example, we can see our latencies there of our URLs, but we can also see that 89% of our traces had an OK response. 1.76 had errors, or not in this demo. You also get a nice waterfall graph of all of your external dependencies and the route that the traffic takes between your microservices and AWS services. So you can drill down into detail and see, OK, that latency figure I saw is probably made up from 12.9 seconds here going to DynamoDB there. So it's a really good way to get an insight into your applications and understand what they're doing. With ECS, you also get CloudWatch built in. Right? So you're going to get monitoring for CPU and memory at a cluster level, but also at an ECS service level. Right? So you're going to be able to graph things like CPU and memory for your services, but also if you're using load balancers, you're going to be able to see the latency for incoming requests, et cetera, all built in by default out of the box. You can, of course, export these metrics to other toolings. So if you're using Prometheus, for example, or Elasticsearch with the Elk stack, there's a couple of open source plugins that allow you to just export your data straight into those solutions. For logging, ECS has centralized logging support built in. So within your task definition, that JSON definition of your containers, you can specify log drivers. So potential options here are Splunk, if you're running Splunk, FluentD. One really nice option is AWS Logs, which will automatically export all of your containers standard out into CloudWatch Logs. Once it's in CloudWatch Logs, you get the UI, the console within CloudWatch Logs. You can search through your logs, et cetera. There's also a really nice feature within CloudWatch Logs called metric filters. Metric filters allow you to specify search patterns, such as error, user couldn't sign in, or something, some sort of text-based search pattern. And when you do that, CloudWatch Logs is automatically going to graph with CloudWatch any occurrences of that log entry. You get a graph, and you can see exactly when they're happening. You can set alarms on that to notify people or systems. But you can also, in that graph, just right-click and view the log entries associated with that point in time. So a really nice way of just tying together metrics and logs. So to wrap up on the ECS side, ECS is a fully managed container orchestration engine. It's actually free as well. Right? So you pay for the EC2 resources for your container hosts. The actual scheduling part of the container, the back end, the backplane, that's the AWS managed bit. That's a free service we offer to customers. You can use things like load balancers or DNS for service discovery. With the ECS event stream, that gives you extreme flexibility over your scheduling options. You have placement strategies and constraints to optimize your cluster. You can use the SSM parameter store to store that configuration and secrets data. Monitoring, you have things like Xray, CloudWatch Logs, all your own tooling. And as I mentioned, it's a free service. So with that said, we've sort of gone over the ECS side. There's going to be a point at the end for Q&A if anyone has questions around ECS or anything else in this talk. I want to talk a bit about something that we did recently, which is join the Cloud Native Computing Foundation. Did anyone see this announcement? Yeah? OK. So we joined this a little while ago, back in August. And there's been a lot of questions and speculation around our reasons for doing this. And I just wanted to cover that off and tell you our thoughts behind that. So the Cloud Native Computing Foundation covers 12 super interesting open source projects. Open source projects that are interesting both to AWS and to our customers as well. So a lot of people, there was a lot of speculation around Kubernetes, et cetera. Actually, we're interested in a lot of these projects. Some real examples here. You'll see that we've already contributed towards things like Containerd. CNI is another one here. So for ECS, we're working on container networking, right, to be able to use AWS networking primitives with your containers. We're doing that with CNI. So the CNI specification for container networking is what we're using. And you can actually go and read up about that on GitHub. We're developing that in an open source community model. And it's on the ECS agent page. You can see all around our plans for integrating CNI with ECS there. So while Kubernetes is super interesting to us and our customers, our vision here for joining the CNCF is actually a lot bigger than that. That said, the CNCF did a survey recently. And apparently 63% of people that run Kubernetes run it on AWS. And thinking back to our goal earlier of making AWS the best place to run containers, no matter what your choice of orchestration engine is, clearly we want to make AWS the best place to run Kubernetes too. So we're going to be contributing back to the Kubernetes project as well as some of the other CNCF projects as well. I know there's been a lot of speculation around is AWS going to run a managed service, et cetera there. Just to save you all putting your hands up in a minute, I can't talk or comment on that at all. That's not an area that I'm going to cover today. So sorry if that's the sole reason you came to this session. OK, so we talked about the choices, the main choices there between Kubernetes, ECS, et cetera. Who's using what on the platform? So it turns out there's great stories on both sides right here. So people like Expedia, Travelex. Travelex is super interesting. They're running a PCI, FCA regulated workload on ECS. OK? They're really, really interesting story. They've done some very interesting stuff around container security for containers talking to other containers. Their mantra when I've spoken to them before has always been, we've got the regulatory requirements, but we want to go more. So it's super interesting. There's a video actually on YouTube where we actually drill into their architecture and go through it. Search for Travelex, this is my architecture, and you'll find it. Amazon, another big user of ECS as well. There's some talks that we've done reInvent before talking about how Amazon uses ECS for generating recommendation engine stuff with Spark, for example. GoPro did a really cool case study recently. You can go and watch a video where GoPro talk all about their usage as well. And then using Kubernetes on AWS, you've got people like Monzo Bank trying to revolutionize the banking world. These guys are super open about their usage. They've got a really good tech blog you can go and read up about what they're doing. They're using Linkerd heavily as well for service mesh. Very interesting. Zalando, big European retailer, and also Ticketmaster. So Ticketmaster, actually, I brought along Rick with me. So Rick has come from Ticketmaster. He's going to dive deep on Kubernetes. He's actually came to me and said, I want to do quite a big demo. He's going to deploy a whole cluster here live on stage and deploy some services to it. So it should be a really good demo. Rick, you're up. You've got the HDMI there.
I'll take that.
Look at there if you want it.
All right, bear with me, guys, while I set up. Right, guys, so Paul asked me to come here today to talk to you about Kubernetes and the way that Ticketmaster are doing it on AWS. I'm going to tell you a couple of ways Ticketmaster are doing it on AWS because there's lots of ways to run this, and we've got a couple of ways we do it internally. So I'll explain those reasons as we go through. There we go. Well, first of all, a little bit about me. I'm Rick Harvey. I'm a contractor with Ticketmaster. I came in to help them with their Kubernetes products. I've also been at Channel 4, Six Nations, and Ticketmaster in a previous life as well. And I specialize in doing migrations from on-prem data centers into AWS. So I've been doing this for quite a while now. I'm Rick without the K as well, as you may have noticed by the picture. So Kubernetes. Ticketmaster have two primary ways of doing this. We use Tectonic and we use COPS. I'm going to go deep on COPS today and tell you about how we use COPS. But first of all, let me tell you about Tectonic. Ticketmaster is a very, very large company, and we have different products all around the world. The US guys run Tectonic, and this is primarily because they have very, very large clusters. They have multiple products in there, so it's a multi-tenanted deployment of Kubernetes that need to be kept separate in namespaces. And there's a lot of data being transferred between. So things like etcd, which is used for service discovery and configuration management within the cluster, is very, very busy. Tectonic support having your own separate etcd cluster on the side, and this makes a very, very, very fast cluster for you. International, which is the UK really, we use COPS because we have a bit of a different deployment mechanism. We tend to isolate products or product groups into their own VPCs in AWS. So when we come to deploying Kubernetes, we end up with one cluster per product group. Now, if we're having a separate etcd cluster for every one of these, as you can imagine, we'd have lots and lots of instances, and the cost would rack up very, very quickly on EC2 costs. So it's kind of why there's two different deployment mechanisms. They're both pretty awesome ways to do. Tectonic is a licensed proprietary deployment. You'll need a license key. You can run it for 10 nodes free. COPS, on the other hand, is an entirely open source product. Another reason for us using it, because it's free. So let me just skip back. Our deployment environments. We tend to use Terraform for everything we do in Amazon, so we can repeat it, we can replace it if there's ever a disaster very, very easily, and we can spin up other environments. We can spin up dev, test, QA very, very easily from that. Now, this causes some issues when doing some of the deployments, but there's ways to work around it, which I'll dive into. Everything that we do in AWS, we tag, and if it's not tagged, it gets deleted. So if a dev comes up and spins up a few EC2 instances that we don't really know what they're doing, and they've not tagged them with the product code, environment, and what the application is, it will get deleted within 15 minutes. So it stops people Bitcoin mining on our AWS account, basically. We try and do everything to best practice. So when we create VPCs, we have public subnets and private subnets, and The only things that really go in public are Bastion hosts and elastic load balancers. Everything else is in public, and we use network access control lists and security groups to look after the ingress, basically, and egress. So why did we use Kubernetes over ECS? Well, one of the big reasons was the community. There's a lot of help out there, and a lot of our guys are very, very active in the community, contributing code back to the Kubernetes and to the Tectonic products at the same time. So it was very, very easy to get involved in, get help with, and pass ideas around. So that was one of the main ones. The kube control. Now this is the key to Kubernetes cluster. It's the way of connecting in, running your workloads, getting information out. It's a very, very powerful tool. It's very similar to the ECS CLI tool that you've got. One or two advantages of it is you can actually drop direct into a container for debug purposes. So a bit like with Docker, how you can run Docker exec and drop into a container. You can do the same with the kube control tool across the network. It will automatically find the host for you, will find the container and connect your laptop to that container. So it's very, very good for debug purposes. We have a large amount of products. So orchestration is key to everything, being able to repeat it, replace it, update it. Kubernetes is great for that. Just like ECS, you have either a JSON, or in our case, we can have a YAML file as well. I don't know about on ECS.
ECS CLI does.
Yeah. So we can have JSON or YAML, bit the same. You define your services in there. Now, Kubernetes has some slightly different concepts to ECS. Pods are a collection of like-minded containers that you put together. A pod's quite clever, actually. It shares a local host network. So if I was to spin a pod up with a Apache web server and a MySQL database, I could write code that runs on Apache that talks to localhost 3306, and I get into my database without having to do large amounts of service discovery extras on top. It's there by default in the concept of a pod. You can also have what used to be called replication controllers. Now, these are ways of scaling your pods. So you might want several copies of your Apache or Nginx front end. This has been replaced recently with something called deployments. It's a similar kind of concept, but a little bit more powerful. We mentioned about constraining where you want to run your workloads. This is a relatively new concept in Kubernetes as of 1.6, I believe. Taints and tolerances. We always used to be able to label Kubernetes workers, the nodes, and give them things like, say, this has got SSD attached to it. This one's in EU West 1A, 1B, 1C, so you could attach EBS disks to it on the fly. So your container would have to run in a particular AZ to connect in. You could do that with labels, but now you do it with something called taints and tolerances. They're slightly more powerful set of verbs to describe how you're going to connect together. And by that, I can say, if application A is running on this server, never allow application B to run on here. In fact, don't let anything else run on this server because you may have issues. On the inverse, I can say, but this is a dev box, so I'm going to tolerate it running on there and allow you to squash it down and give it performance problems because it's only a dev container. This allows you to mix your workloads a lot better and get very, very dense deployments. So why COPS? It gave us the ability to deploy into our existing VPCs, which are all terraformed. I've mentioned the cost savings already with etcd. And rolling updates. Now, this is a pretty cool feature. If anyone's ever built a Kubernetes cluster by hand and tried to do updates, it can be very, very painful. You can end up completely toasting etcd, which is all your config and state, get split brain. You're in a world of pain. The COPS tool takes care of all of this for you. It just works. And then we've got the fact it's also a community-led product. and it's in the Kubernetes GitHub, so it's a very, very responsive area. Right, guys, so this is where I'm going to try and show you the power of kops and hope everything works in a bit of a live demo. So with this, let's just flick over to my terminal. Now, you might be able to see I've got a backup there waiting just in case. I'm also going to flick over to my EC2 and S3 consoles, just to show you I'm not cheating. So when we do a deployment, kops uses an S3 bucket to handle things like PKI and the cloud init configs that are going to be consumed by the cluster as it boots. Show you I'm not cheating. Here's an empty bucket. Nothing special, guys, but just to prove I'm not cheating. And I'm going to run this one in Frankfurt because I've got no workloads in Frankfurt at the moment. So you can see I've got no EC2 instances. OK, so when we're running this, I'm going to cheat and copy a lot of stuff over to my other terminal window, just because I'll probably fat finger sync if I try and type it live, and it won't work. So we're going to set up our kops demo. Contain.io is our domain name. And we're going to set a few things up. I showed you that S3 bucket as well that I'd created. And we're just going to set this up in our shell session so we can refer to it by variable. So I don't have to retype that every time. It's relatively simple. What we're going to do here, we're going to run create cluster. Now, when you create a cluster like this, kops is going to create everything for us. It's going to create a VPC for us. It's going to create the security groups, NAT gateways, all the subnets will be set up as well, and the route tables, and everything will be there for you. In this particular demo, I'm going to give us a multi-master setup. So we've got 3 masters, 1 in each AZ, and I'm also going to ask for 3 workers, 3 nodes. I've told it topology private. Now, this is quite important. The topology private will mean that all my instances get deployed in private subnets within AWS, and the only way we're going to have ingress into that is via elastic load balancers that are going to run in the public subnets. Kops takes care of tagging all our subnets for us as well, so Kubernetes can understand what goes where. So let's run this command first. What this is doing in the background is it's discovering what we've got over in Frankfurt. It's going to set up some. It's going to set up a cider block for us. It's adding some entries into DNS ready for us to go, and it's creating PKI certificates. Now, these PKI certificates are quite important. These are the things that allow nodes to talk to each other directly. Now, when I refresh this bucket, you see I've got my cluster in here. And if we dig into this, you can see we've got PKI, cluster spec, and config. Config being cloud init. Instance groups I'll cover in a second once we get going. I'm going to tell it to spin up now and then take you through it while it's doing it. So, rather strangely, create cluster doesn't actually create any AWS instances for you. It just sets everything up. The next command that we run, which is update cluster with a yes command on the end, got the right one, is actually going to instruct the API on AWS to go and create our instances for us. So we're going to let that run in the background, and as it comes up, everything's going to get created for us. And we should see very, very quickly we'll start to get instances in this console here. We'll flick back in a moment. Let's have a look at a bit of a slide while we're doing this. So this is what we're trying to achieve. We want an auto-scaling group for each master. Now, the reason why it's in an auto-scaling group of 1 is if that master fails, it will get replaced. Attached to this auto-scale group is an EBS volume that gets attached to the master, and that holds etcd for us. In this case, it's actually encrypted as well, so it's encrypted at rest, so all your configs and your secrets that you put into Kubernetes are secured at rest. We've then got a big auto-scale group with all our workers in. We've told it to have 3 for now. In COPS, we call this an instance group. And an instance group is basically a collection of worker nodes for you that you can add labels to. These labels are important for the taints and tolerances that I mentioned earlier. And we can have multiple instance groups. We can actually go into the COPS command line and say, give me another instance group. And we could create another instance group. We could tell it to only span 2 AZs, for example. And we could say within that instance group that we want them to have provisioned I/O disks. And we want to put on a taint there that only allows database containers to connect to them. So we've got high I/O on the back end if we're doing stateful sets. So we can have multiple tiers of this, and we can also go into the nitty-gritty within COPS and add extra subnets in there. So we could separate masters and we could separate instance groups out into their own subnets with AWS. It's all doable from the main command line. All right, let's see if we've got anything spinning up yet, guys. Right, okay. Whew, it's lucky. Right, we've got 3 masters and 3 nodes being created. I'll talk a little bit more why these initialize, but if we have a look at our console, we've finished giving the commands. It's all now in the hands of Amazon Web Services, so it should work. Another thing the COPS tool does for you, it sets up your kube control config. So this is your set of certificates you have on your local machine to be able to connect in and authenticate. Now, if we just give this a quick view, you can see I've got 2 configurations here. If I move this higher up the screen, you can see anyway. I've got the backup cluster just in case this wasn't going to work. And in yellow highlighted is the cluster I've just created. This is all set up for me magically. COPS has taken care of PKI. It's created certificates for the users. It's created passwords for the dashboards. Everything's done for you. So it's very, very handy. And if you've ever built a cluster by hand, you know how much time this can actually take while doing it. So let's see if we've got any status coming. Yeah, I very much doubt it because we're under 5 minutes. But so yeah, our load balancer hasn't come up yet. Well, it's come up, but we've got nothing connected. So it's another one of the resources COPS has created for us, a load balancer for the API. You can go in and specify when you create this, you can actually do some funky stuff and enhance the security groups on there. By default, the security groups are pretty open. That doesn't mean have a go at connecting to my cluster, please. But it's all good. So I can show you, while this is booting up, a little bit of how COPS describes a cluster. So this is our COPS configuration. This is what gets stored in S3. We've got specifications of the etcd service. etcd runs on the masters. That's where our big cost saving is in the international. As you can see, the API access is a little bit open there with a 0 range on. You can also go in and update the version of Kubernetes you're running. I think 1.7.6 is the latest stable, so you could tweak that and then apply a rolling update, and it'll push that out to the rest of it. Here's our subnets. Now, if you're going to deploy into an existing subnet, this is the bit that you'll be tweaking around. It's not very well documented at the moment, but this is the bit you're tweaking. You have to have a private and a utility set of descriptions. Private is where your masters go. Utility could be a separate set of subnets. Yet again, it's a private subnet. In the utility ones, we have to specify NAT gateways, things like that, because these are the ones that can't connect out. So we go in and do that ourselves. And then, as I've said, everything's private on the topology here. We've got private on both, but my DNS is a public DNS, so that's fine. My DNS is in Route 53, it was a pre-existing zone there. You can use external providers, but it just works really, really well with the integration with Route 53. If you was to edit this, once you've done it, you run a COPS update cluster, and it'll tell you what changes it's going to make, and then COPS update cluster with a -- yes on the end, and it'll do the updates for you. If you're doing something that's going to change existing nodes that's up there, there's also a concept of rolling updates, and that'll get pushed through as well, which is really quite cool. So let's see what we've got. Hey, so we've got some nodes running. As you can see, 2 of them are reporting not ready yet, but they'll be here in a few seconds or so. This is all my resource that I've created on AWS. There's 3 masters, 3 nodes in here. So we're getting to the state where we should have ready on everything. Another watershed moment there that we've passed. So at the moment, it's not particularly impressive. We can go a little bit deeper. So kube control, get nodes from the namespace, kube system. You'll see what's been done and configured for us in the background. Oh, let's get the pods instead of the nodes. You see we've got quite a few things running for us, all in containers. So we've got the controller manager, the API server, the proxies, kubedns, the scheduler, and we'll also have a few Calico nodes up here because I picked Calico as a network CNI module. You can also swap that quite easily for things like Weave or Flannel. It's just a flag you change. So it's very, very, very easy to change stuff. Right, so I kind of wanted to show you something that looks a little bit prettier than a command line. So I'm going to hop on here and I'm going to tell our cluster to first of all have Heapster. Now, Paul talked about monitoring. Heapster is a way of getting some statistics out of our nodes and into various things. You can plug into Prometheus quite easily. There's a very good Prometheus plugin. There's some open source projects to push into CloudWatch and stuff as well. I'm just going to do it locally, and I'm also going to create the dashboard for you. So if we have a look at this dashboard YAML file, it's just very, very similar to what Paul was showing you. There's a little bit more in it because the dashboard has to have role-based authentication, RBAC integration into it. But at the heart, we're specifying a container, the version of the container, and we're also specifying some ingress into there, which in our case is an elastic load balancer. So if we now have a look at this pods that are running, somewhere in this, right here at the bottom, we've got the Kubernetes dashboard up and running. Now, I mentioned services, so this is quite important for what we're about to do next. Services. So I don't have an external IP for that, never mind. Yeah, so the dashboard here is running locally in my cluster, and I've got no service connected to it at the moment. I'm not quite sure why. Let's have a quick look at our config. So we'll come back to that one in a bit.
You didn't pray to the demo gods for it?
I didn't, no, I didn't pray to, I didn't do my sacrifice. Let's hope the deployment works a little bit better here. So what I'm going to try and show you is how Kubernetes can actually link in with the AWS features, and we can go in there and we can get it to create a load balancer for us to open our service up so we can actually use it. So here, first of all, I'm going to ask it to just deploy the stock Nginx Am I in the right directory? The stock Nginx. Let's create the namespace first. So namespace is a way of logically separating your applications from each other. Quite useful for if you've got lots of deployments and go multi-tenanted. All right, that one worked. So once we've got that up and running, we're going to end up with 3 Nginx servers spread out across our cluster. And what I want to do now is expose this. Exposing basically creates us a load balancer and it connects it back into our Kubernetes cluster. At the moment, the default integration with Kubernetes is via Elastic Load Balancer, not Application Load Balancer. Ticketmaster are working with CoreOS on an ALB ingress controller. So hopefully that's something that will get moved along soon. Okay. Right, yeah, I'll pick those up in a moment. So now I've exposed our service. What we need to do is have a look what it's called our load balancer first of all. And when everything comes up and connects and goes through, it should all be happy. So we'll have a new load balancer here that Kubernetes has provisioned for us. We're just waiting for the instances to come into service. And as soon as it does, I'll show you the default Nginx page, which is really, really exciting. But it will work this time. OK, so right. So there's a question here on Twitch. Can Kubernetes and COPS synergize with ECS? Not out the box. You've got 2 areas for your containers to run. You've got ECS, you can have containers in there, and you've got Kubernetes spun up by COPS, and that's the kind of siloed. You could use something like Console to put a service discovery across the entire set of clusters that you've got running, and you could use service discovery like that externally to try and connect things together. There'd be a little bit of work probably to do on the side of security groups and everything, because by default, the COPS cluster that's come up allows COPS nodes to talk to COPS nodes and nobody else. Anything else?
The other question on Twitch, and you'll need to repeat this into your mic, was around the auto-scaling group with a count of 1 for the master. Just a quick sentence or 2 on why you did that.
Okay, there's a question about why does the auto-scaling group for the master have just 1 node? Now this is for auto-healing, not auto-scaling really. So if our master was to fail in any particular availability zone, the auto-scaling group will take care of it and just replace it with a brand new one. So if it detects failure, it will get replaced. Or if you kill it accidentally, it will get replaced. So that's why we use that. Right. Fingers crossed, everybody. There you go. Welcome to Nginx. So this is a really, really simple demo to show you that within 10 or so minutes, we got a cluster up and running, we got connected in. And that's how easy it is nowadays to actually consume EC2, use Kubernetes on top, which before used to be quite a pain to actually get all that up and running. So it's a big step forward. There are lots of other tools you should look at. There's KubeSpray. It's either Kube AWS or KubeUp. I can't remember which one it is, but one of them's become COPS. The other ones are still a separate product. There are lots of ways of doing this. That's it really, guys. So that's all I have from now. If anyone's got any questions for Paul or myself, please get in touch with us.
We're also going to be around for a bit anyway for the next, well, I'm going to be here for an hour or 2. I'm not going to sign you up for staying longer if you're planning on leaving, but We're going to be around a bit as well if people want to chat about specific architectures and stuff around containers. But if there's any general Q&A now, more than happy to answer questions.
So with ECS,
Yep.
what data goes through the ECS system versus what's kept local to your EC2 node?
So your container and your data runs on ECS. On EC2, sorry, on your instances in your control of your VPC. The bit that goes through the ECS backplane service is the scheduling information. So you'd send a task definition, say, hey, ECS, run these containers on my cluster somewhere. The actual containers, the data and stuff around that, that's on your VPC, your instances and stuff. But yeah, we're actually completely out of time. We've overrun a bit. So if you've got questions, come find me or Rick.